Welcome to the 2017 JPI Silica Training for everybody who couldn't make it to the in-person training. It's pretty brief, but it's important that you click the audio on each slide because there is a quiz at the end that you will have to pass. Otherwise, you'll have to listen to it again. This is required that every single employee have gone through this training required by OSHA. These standards are in place as of this summer, but OSHA is not going to start citing people until September 23rd. So we have basically a couple of weeks to get everybody trained and up to speed and get everything implemented from this new OSHA standard. The objectives of this OSHA training is for you to be able to recognize sources of silica. For us, it's basically concrete, cement, brick. So you'll learn to determine what is a source of silica and how you can avoid it, and describe the health hazards resulting from overexposure to silica dust. And then we will describe the methods that we are going to use to control exposure in the workplace. Silica is something that's always been around. Glass actually itself is made of silica. U.S. workers are exposed to respirable crystalline silica, which is what's dangerous, in a variety of occupations, including construction, sandblasting, mining. Luckily for us, there's not a whole lot that we do that leads to prolonged silica exposure, but it's in just enough of some of the surfaces that we attach to or have to fasten to that it is going to have an effect on your day-to-day job. So basically the point of this is to determine what has silica in it and what can we do to prevent breathing silica in during your workday. So like I said, silica is basically a type of sand. It's a type of quartz. It's the basic component of rock, sand, granite, soil, many other minerals. And glass, if you've ever seen how glass is made of silica. But it does not become dangerous until you start drilling, grinding, chipping, breaking up, and otherwise making those particles so small that they can become respirable in the air. What is crystalline silica? That is the subject of this new OSHA rule. And it's basically respirable sized silica, crystalline silica. Quartz, for example, is the most common form of this. And then all forms of crystalline silica can become respirable sized particles when you chip, cut, drill, or grind objects that contain crystalline silica. Here is a enlarged photo of what silica particles look like on a filter. And we will talk about how extremely small these particles are in just a little bit to give you an example of what a small amount of silica we are talking about. So why do we care about silica? It's because it has detrimental health effects for people that have been working in industries and exposed to respirable silica for long periods of time. They're starting to determine the impact of that exposure on people's health in especially fields like mining, people that work in factories that make glass, people that work in like drywall factories, concrete workers, professions like that have seen some health issues over the years. Crystalline silica can lead to silicosis, is the main disease that comes from silica exposure. It's a non-reversible lung disease. So basically, once silica dust and silica particles get into your lungs, you cannot get them out, which is why it's so important to prevent that exposure in the first place. It can be a fatal lung disease, and it is caused by breathing in a large amount of crystalline silica. So silicosis on its own is bad enough, but it is also a cause of a lot of other health problems. Some of the ones listed here, like obstructive pulmonary disorder, cancer, lung cancer and other types of cancer, TB, renal disease, stomach cancers, immune diseases. So silicosis itself is a fatal disease or can be fatal, but it also can lead to a lot of other health problems and other health diseases when you're exposed to it over the long term. Some of the symptoms of chronic silicosis, there are not really symptoms in the early stages typically, but as the disease progresses, it can lead to cough, breathlessness, weakness. This is something that, other professions that deal with silica on a prolonged, and I'm talking more than 8 hours a day, every day, that they are at risk for. So the silica safety standard has changed. There is an old silica safety standard. This new silica safety standard is much, much more strict. What you need to know is the permissible exposure limit, or PEL. You'll see that on a lot of the charts that we'll be distributing to people. And here is the old formula of how you can calculate the amount of silica that you can be exposed to based on the size of the room that you're in. And so this is not something that you guys have to worry about calculating. This is something that the project managers, the general contractors will be concerned with and will implement with the foreman the proper controls when you are working in an area where you're going to be exposed to silica. The new OSHA silica standard requires that we measure the amount of silica exposure to workers and determine if it's at or above an actionable level. And they average that over an 8-hour day. So that is, like I said, something that the project managers and the general contractor will work together on and determine before the start of the job. Another requirement is that we protect workers from respirable silica exposures above the permissible exposure limit of 50 units per cubic meter averaged over an 8-hour day. So we have some protections in place that I'll go over here in just a minute, but it's our job as your employer to make sure that you are protected if you do have to work or be exposed to crystalline silica. Standard also requires that your employer limit your access to areas where you could be exposed to amounts of silica above the PEL. For us and for most trades, this isn't always possible. So you limit it where you can. For us, we don't really work in areas where we can avoid. If we could avoid fastening into concrete, we would, but a lot of times there's just no avoiding it. So in the absence of limiting access or just not working with those materials at all, the standard requires us to use dust control or respirators to protect people from silica exposures above the PEL. So they call this, the OSHA standard refers to this as engineering controls, when you have to use things like the dust control vacuum, the hammer drill vacuum, things like that, or PPE, so silica PPE, which will be your dust masks when you have to use dust mask respirators when you're working with silica. Standard also requires for us to restrict housekeeping practices that expose workers to silica where it's feasible, or where feasible alternatives are available. For example, this would include things like on a project management side, if say we have a track that needs to go in a concrete floor, instead of saying that we will go ahead and drill that out, we are going to be asking general contractors that they block that out when they're pouring the concrete, things like that, to avoid having to deal with concrete or cement or brick whenever we can avoid it. So this is going to change the way that we deal with things like thresholds, if we have to grind down concrete, putting tracks in the floor, things like that. So it's something that the office will be working on at the beginning of a project to avoid being exposed to that at all, or that you guys will have to look at when you're actually out on a job site and the GC asks you to do something like grind some space, where concrete needs to be changed, or anything with thresholds where you might have to do any grinding. That's something that we will have to look at on a case-by-case basis and just something to be aware of. Finally, the standard requires that we establish and implement a written exposure control plan that would identify tasks involving exposure and the methods used to protect workers. So I have, it's a probably like 20-something page written plan that we have. It's available to you guys at any time. Anytime you want to look at it, talks about the tasks that we specifically deal with and what we do to protect people from silica. This is something that general contractors are now starting us to require us to give them when we start a job. So it's something that they will have on file, and it will also go into the safety manual books that are in your job boxes or Connex or that you should have on site. So that written exposure control plan is complete, and it is available for anybody who wants to look at it. Doesn't apply to us as much because we don't really have prolonged exposure to silica. But in industries and professions that do, employers offer medical exams for people that are exposed at or above the actionable level of silica, which means working with silica for over 8 hours a day for 30 or more days per year. Standard also requires that the employer train workers on work operations that result in silica exposure and ways to limit exposure. So that's why we're doing this training. We'll be doing some on-site training and some ongoing information will be provided. This rule has not even been come into effect in terms of enforcement yet, and so there's a lot of things that OSHA has been really vague about in what's acceptable, what we're allowed to do, mitigation, things like that. So more guidance is going to become available as it goes into effect. Unfortunately, that, things that they haven't figured out yet, that they will be figuring out as they go. And so as we get more information, we will be passing that along, doing some continuing education, and providing you with whatever sort of resources you need to stay safe when you're working. We also have to keep medical records of workers' silica exposure and medical exam. This isn't something that really will be dealing with much, but for example, if somebody were to have some sort of silica-related illness, we as an employer are required to keep those records for the duration of employment plus 30 years. So getting into the specifics of what is allowable in terms of respirable silica. The PEL, which is the allowable limit for respirable silica, is 50 micrograms per cubic meter of air averaged over an 8-hour shift. So there is the little equation there on the screen. So what's significant is that this is a reduction from the previous OSHA standard that has been in effect up until July of this year. It is a reduction from 5,000 micrograms per cubic meter, which is what has always been allowed, to 50 micrograms per cubic meter. So that's a huge reduction. It's a 99% reduction in what is allowable. So it's a enormous change for all industries that deal with silica. A huge reduction, as you can see, a 99% reduction in the amount of silica that a person is allowed to be exposed to without taking any sort of mitigation measures. How much is a microgram of silica? To give you an example, 1 teaspoon of granulated salt is 5,600 milligrams, and 1 teaspoon of silica sand is 7,700 milligrams. So that's milligrams. The standard talks in micrograms. So 1 milligram is 1,000 micrograms. So you can see just what a minuscule amount of material we're talking about when you're talking about 1 teaspoon of silica sand is 1,000 times 7,000. So it's a really, really small amount that you're talking about when it comes to micrograms of silica dust. To give you an example, how much silica is in this room. So just pretend that the room you're in has these dimensions, and that would come out to be 269 cubic meters. So that's the space of the amount of air in the room that you're in. So then say that we have 2,800 milligrams of silica flour. So that's about 1 teaspoon of silica flour. And we're going to say that in that teaspoon, 5% of it is free silica, which is what we're concerned about breathing in. So you would run this calculation considering the 1 teaspoon of silica in the room, that is 269 cubic meters, and that would give you 523 units per cubic meter. And our limit now is 50. So 523 units is greater than 50 units. So we are above the allowable limit. So we would have to use protective measures when we were working in this room, if we were going to be enclosed in this room and working. So that kind of gives you an example of the amount of silica that is allowed in a room. It's very, very, very small. What you do about it, you have to try to reduce your exposure to silica. So this rule written is quite vague, and so it doesn't deal specifically with any particular trade. So here are the suggestions that OSHA gives that ways for you to reduce your exposure. You can substitute materials that have no silica. So we don't have any control over the building materials that we are fastening to, so that's not really an option. Locate employees as far as possible from the dust generation source. Of course, if this is an option, we should do so. That's not usually an option. I mean, you have to be with that frame fastening it into that material. So that's not really a feasible option. Isolate employees or the source with barriers or enclosures. Again, not exactly a feasible option. Then they say move employees further from the point of exposure. Can't really do your job if you're across the room from your material. Use local exhaust ventilation systems. I have a feeling that this is something that will come into play. You'll see more often with GCs if they are able to do that. And finally, the way that we're going to be able to control this is with dust collecting systems on our tools. And so that's what we're going to focus on here today. One adaptation that we can use with our tools is use wet methods when cutting, chipping, drilling, sawing, or grinding. This is not something that we are going to be able to use very often, just because you can't get your surface wet and then continue to work on it and do your job properly. So if we can use wet methods, we will look at that. It's not something that we're going to be used to meet the standards very often. Another thing that you can do is clean the surfaces with HEPA vacuums. You cannot just use like an air compressor. You can't just sweep it off. There are very specific ways that we have to deal with silica. So you're going to, if you're dealing with silica, you have to be using a tool or a machine that is equipped with the proper vacuum. So it has to be a HEPA vacuum, not just any old vacuum. That brings us to the chart. This is the chart that OSHA has supplied. I have condensed this and taken out some of the tools that we don't really use in our trade, like a stationary masonry saw. I've taken out things like that to condense this down to a one-page double-sided document. So this is laminated and it's going to be given to everybody, every job site in your job box or your Connex. If you want a copy for yourself, just let me know and we will get you a laminated copy. You can keep it in your vehicle. It just helps you just look back and refer to it instead of having to try to memorize some of these requirements. So let's look, for example, at number 2, the handheld power saw. So what they're saying here is that you have to use a saw equipped with integrated water delivery system and operate it in accordance with the manufacturer's instructions to minimize dust emissions. So this is the controls when you are able to use a power saw and you are able to use it wet. when that applies to us. If you're able to do that, here's what you have to do. When you're using it outdoors, you do not have to have respiratory protection if you're using it for 4 hours or less. If you're using it outdoors for 4 hours or more, you see that APF pin there under the required respiratory protection section of this chart. That means that you have to be using a dust mask. It's not a full-blown respirator, it's a dust mask. If you're using a saw to cut a material that contains silica for more than 4 hours at a time, you have to use a respirator. So that's kind of what this chart tells you, when you have to wear a respirator or not, and when do you have to use a dust collection or wet cutting method. So here is handheld grinders for uses other than mortar removal. It tells you for tasks performed outdoors, where it's underlined there, that you do not have to use respiratory protection. If you're using it indoors or in an enclosed area for more than 4 hours, you have to use a dust mask. And then it tells you water controls over on the right-hand side and dust collection system. So we will be using the dust collection systems. And so these are pieces of machinery that are going to attach to your grinders, your saws, and your hammer drills that you will have to use anytime you are dealing with silica. So you don't get to choose whether it's indoor or outdoor, or whether it's 4 hours more or less. You always have to use that vacuum system when you are working with a material that contains silica. So you just need to remember, anytime you're working with cement or concrete or brick, you have to use that dust collection system no matter where you are, inside or outside. And then you will need to look at the chart if you're working, whether you're working under 4 hours or over 4 hours, to determine whether or not you need to be using a dust mask respirator. Here is the APF chart that tells you what is allowed and what is sufficient to meet those requirements. The APF 10 is a dust mask or half mask, and this is what we are going to be providing everybody with. Everybody will get dust masks provided to them. So there are times where you will be required to wear them, and there are times where you'll be dealing with silica dust, or maybe you're working around another trade that is, where you may not necessarily be required to wear them, but they will be provided to you and you can wear them at your discretion. So if you feel more comfortable wearing the mask, then by all means wear it whenever silica or dust is in play. And then you'll be responsible for knowing when you have to wear it per OSHA guidelines. The Hilti dust removal system, this is the hammer drill attachment. This is going to be provided. Right now we're rolling it out to the foreman for all of their Hilti guns, and it's something that we will be providing to everyone else kind of on a case-by-case basis. So we're going to kind of see how it goes, test it out for the next couple weeks before the rule goes into full effect, and we will see if we need a lot more or if 1 or 2 per job site is going to be sufficient. So we're going to need you guys' feedback. Let us know how it's going and whether the Hilti products are working for you, because the OSHA did not take into consideration all the different variables of how we're doing our work when they made these rules. So we just need to know, is this vacuum doing its job, and can you still drill into a subsill, and can you do your job and meet the requirements of this rule. That concludes the silica dust training segment. So just to recap, we have to pay attention to when it's feasible, use materials that don't contain free silica, use engineering controls like Hilti attachments or HEPA vacuums to try to control the dust when we are able. Use controls to keep the persons away from the dust and not work in those areas if we are able to. Implement a written silica control plan. This is in place and we have a copy of it, PDF, that I can email or print out for anybody that wants to read it. Use medical evaluations for anyone who's exposed to silica for more than 8 hours a day for more than 30 days in a year. And use personal protection equipment, respirators designed for silica protection, and in our case, also using things like our Hilti hammer drill, vacuum attachments. We're going to have saw attachments, grinder attachments, things like that. And so if anyone has any questions, this is a kind of a broad overview, and there are a lot of moving parts with this rule and its implementation. So there's a lot of things that we're going to just have to figure out together and work it out so that we can still do our jobs efficiently. Talk to any one of your project managers, or give me a call or email me if you have any questions, and give us your feedback as you go as to ways that we can do this as good as we possibly can. So I have a little quiz that you have to pass in order to have successfully completed silica training. So the link to the quiz is in the email. So go to the quiz, complete it, and then you will get your confirmation that you are done with silica training. And if you have any questions, make sure you let us know. I will be sending out the chart. It'll also be attached to this email, and you can request to see the silica written plan itself anytime. I will also send a link to the OSHA website that talks more about the silica rule, what is silica, and all of those complicated mathematical equations for anybody that wants to read into this further. So thanks for listening, and let us know if you have any questions, and we will start working together to implement this new silica rule.